Imagine this. Somewhere in the deserts of Southern California, not far from the town of Mojave, there is a stretch of land where experimental aircraft have been tested for decades. This empty patch of area is far from major population centers. These humid and dry conditions make it ideal for flight testing, especially for aircraft that did not fit standard rules or expectations. This is where many of the most unusual airplanes of the late 20th century were designed and flown. Many of them came from one designer known as Burt Rutan. Before we begin, do subscribe to our channel so you never miss the next story. Rutan was not part of a large aircraft corporation for most of his career. He did not work inside a system focused on mass production or airline sales. Instead, he worked with small teams and aircraft built to answer specific questions. His company, Scaled Composites, was based in Mojave and remained small compared to major manufacturers. Aircraft built there often looked strange to the masses. Some had no traditional tail. Others placed engines behind the wings instead of in front. Many had long, thin wings that flexed in flight. To pilots and engineers trained on conventional aircraft, these shapes looked risky or unnecessary. But Rutan was not designing for appearance. Each aircraft had its own purpose that was based on its mission. Its weight limits and how much fuel it needed to carry everything was molded in accordance to it. Anything that did not directly support the mission was removed or altered from the design. Before Scaled Composites became known for record-setting flights and space projects, Rutan first gained attention in the home-built aircraft community. In the late 1970s, he designed aircraft such as the Vari Ease and the Long Easy. These were not factory-built airplanes. Instead, they were sold as plans. Builders received drawings and instructions by mail and constructed the aircraft themselves. Many worked in garages, barns, or small workshops. This approach appealed to pilots who wanted efficient aircraft and were willing to build them on their own. Not everyone trusted these designs. Some pilots found the handling unfamiliar. Others were cautious because the aircraft did not look like traditional airplanes at all. Still, the results were clear. Thousands were built under his ideas, and they flew successfully. Rutan also focused on materials that were uncommon in aviation at the time. Instead of aluminum, he used fiberglass, foam, and later carbon fiber. These composite materials were lighter and allowed smoother shapes. They also reduced the number of metal fasteners and joints. Over time, composites became widely accepted in aviation. But at the time Rutan began using them, they were still considered experimental. By the early 1980s, Rutan moved away from designing aircraft mainly for home builders. He wanted more control over testing and development. This led to the creation of Scaled Composites, where aircraft were designed and flown as complete systems rather than kits. One of Rutan's most visible early projects in this new phase was the Beechcraft Starship. Beechcraft invited Rutan to help design a modern business aircraft using composite materials. The Starship was already advanced for its time. It was built almost entirely from composites. It used a canard layout and rear-mounted propellers. On paper, it promised efficiency and lower maintenance. But to his surprise, in real-world scenarios, the aircraft faced problems. It became heavier than as per planned. Certification costs are always high. This leads to a roadblock to many buyers as it doesn't justify the price and pain of the process. Only a small number were sold before production ended. Within the aviation industry, the Starship was often cited as an example of how unconventional designs could struggle in the commercial market. While the aircraft itself flew well, it did not succeed as a product. Shortly after the Starship program ended, Rutan returned to Mojave and shifted his focus away from commercial aircraft. He began working on projects with no expectation of mass production. One of these projects was Voyager. Voyager was only built for one purpose only. That was to fly around the world non-stop without refueling. No aircraft had ever completed this task before. To make this possible, Voyager was designed around fuel efficiency. Fuel was stored wherever space allowed, including inside the wings. The wings were made extremely long and thin to reduce drag. This made them flexible, especially when fully loaded with fuel. The aircraft carried no unnecessary equipment. There was no margin for comfort or redundancy beyond what was required to complete the flight. Fully fueled, Voyager struggled to climb and appeared fragile on the ground. Soon in 1986, Voyager took off from Mojave. Once airborne, the flight became a careful balance of fuel use, altitude, and engine management. Here speed was less important than efficiency. There were no planned stops and no refueling options. Voyager stayed in the air for 9 consecutive days. It crossed oceans, continents, and weather systems that could not be avoided. When it landed, it had completed the first non-stop, unrefueled flight around the world. The flight was documented and verified. After Voyager, criticism of Rutan's design shifted. The discussion was no longer about whether such aircraft could work. The results were recorded and measured. In the early 2000s, Rutan turned his attention to spaceflight. Instead of launching a spacecraft vertically from the ground, he approached the problem as an aircraft designer. Spaceship One was carried to high altitude by a larger airplane before igniting its rocket engine. This reduced fuel use and simplified the launch process. Spaceship One was not designed to orbit the Earth. It was built to reach space and return safely. In 2004, it completed this flight successfully. 2 weeks later, it repeated the flight. These 2 flights won the Ansari X Prize. Spaceship One became the first privately funded, piloted spacecraft to reach space under the competition's rules. The project was small compared to government space programs. The team operated out of Mojave rather than a major space center. Soon after, another Rutan-designed aircraft completed a familiar challenge. Global Flyer flew solo around the world without refueling, reinforcing the same design approach used in Voyager. Across decades of work, Rutan followed a consistent method. Each aircraft was built for a clear purpose. Anything not required to complete that purpose was removed or altered. Designs were tested in real flight conditions rather than relying only on theory. Some of Rutan's projects were commercial successes. Others were not. But many of his designs influenced how engineers thought about materials, efficiency, and aircraft layout. He showed the world that airplanes did not need to follow one standard shape to work, and careful designing can replace excess power, which proved that small teams could complete missions once thought impossible. The desert outside Mojave remains quiet, but the aircraft tested there left a lasting mark on aviation and spaceflight.